All right. Well, welcome to September 16th, Dallas Personal Robotics Group remote night virtual. Just a small group of us tonight, but we got a few topics. So, Mike, let's start off with your progress.
Yeah. So where am I? Too many windows are open. Okay. Yeah. So I try to get my robot to navigate through the hallways, tight hallways, to find the cone and stuff. And I haven't got it to where I wanted it to be, and that is hidden away in the bedroom, and then sort of use a waypoint to say go to this point in the bedroom, and then where it can probably see the cone and then go to it. But I do have a simpler one. It just has to drive through the hallway, and it's a big robot, and it thinks the hallway is a bunch of obstacles. And another thing is maybe the cat will make an appearance, which is another obstacle.
Dynamic obstacles.
Yeah, and also I've been working with the last time I had it, when I first tried to drive into the hallway, it saw the hall and thought it was a cone. the walls, like the edges for the utility room and stuff. And so I decided to make a better different cone detector. So Ray told me that I was saying that I thought Ray was doing the can detection with the LiDAR. Yeah. So I decided I want to try the similar thing with the cone detection, where it sees something that's like you got a big background, and then something's much closer to you, and then it measures the width of number of rays from the LiDAR and gets the distance and says, oh, well, if the cone is so far away from the LiDAR, it should have so many ray points when it's detecting it. And so I looked at the data, worked on it, tried different angles and stuff. And I found one thing is it works pretty good, except sometimes it's like when the LiDAR's right at the edge of the cone, the LiDAR sends back an infinity. Basically, hey, it's not a valid point. And so I had to figure out how to compensate for that. Subtract, basically, like when it's 2 meters away, it's a lot of the width of the cone is infinity sometimes. So the cone is being detected and not being detected because the infinity sort of shrunk the cone size. Because I guess the LiDAR hit the side of the cone, and instead of reflecting back, it sort of just went off into the ether and nothing ever came back. And so it says, oh, well, that's further out than I can measure, so it's an infinity. It can't measure that ray point. Yeah, so I was saying, oh, well, that's the issue with the LiDAR is it's not 100% accurate for every single ray. So I just a couple hours ago I got that algorithm seemed to be sort of working. It probably needs more tweaking, but the idea is like I said before, it sees a cone and you can do the math that says, okay, how many rays should be reflecting back from the cone because that's the number of rays that hit it. And then you say, okay, I need this many rays being detected for the width of the cone, and then compare it to what you expect when you measure the distance. And that works pretty good until it sees the infinities. Then it's not sure if it's the signal's going straight out and just not coming back because it's infinity, or if it hits the cone and reflects away and then doesn't come back.
Shallow, yeah.
So so basically it's just noisy on the whip. So I've got to come up with a really good algorithm to figure out how to compensate for uncertainty.
Mike, I'm a little confused. Is this with your spinning LiDAR, or is this with your...
Yeah, spinning LiDAR. I'm sorry, spinning LiDAR.
Okay.
Yeah. Yeah. It seems that one seems to have the best distance, and then and the other one is the camera, which has the best cone detection, except when it starts to get close, then you want more precision because it sort of jumps around, and you want to really know what it is because you want to drive to the center of the cone. So it's like when it's like 10 meters away, you just need to drive in the general vicinity of the cone. But as you get closer and closer, once you get to like 2 meters away, then it says, oh, I'm going to start using the LiDAR, because the time of flight sensor, the array of time of flight sensors, the non-spinning one, doesn't really go out that far, and it doesn't have enough pixels to really see what's going on that far out. So I said, okay, I'm going to switch from the camera to the spinning LiDAR, and then once it gets a half a meter, a foot away or two, then I'll switch to the other time of flights and pull it in. So I'm going to do a show and tell. I put the cone in the hallway, and the last time I tried to drive in the hallway a couple days ago, it saw the walls of the I said before, of the utility closet, and it said, oh, that's a cone. It was just looking for. It was a really horrible algorithm. So I'm going to pull up. This time I'm going to pull up a Firefox. Where's Firefox? Or Foxglove. Foxglove. And let me start up the program. So on this one, I have a camera here, and I have the area with the plotting and stuff, which shows you the LiDAR and everything here. And I could put on the obstacle, but I'm not going to do that. And then this is the XY direction, XY velocities, like the forward velocities and the angular turning velocities. So you can see that the cone's way over there, and I got my other camera right here, so you can see it's here, and it's going to try to make it over there. And so it should be, there it goes. So you can sort of see that it's the Navigator. You can see the spinning of the blue line is the linear velocity, and the orange line is the angular velocity. So you can see it's trying to squeeze through the doorway. And it made it. It's so close to the doorway, it doesn't like it. Oh, and then you can see through the camera that's going straight towards it, and go. Crap. Oh well, demo.
What's the diagonal black line across the camera sensor?
I don't know. It's only on Foxglove.
Huh.
So and that's, I'm assuming, from the OAK-D light camera?
Yeah, but it doesn't show up on RBIS.
Yeah.
It's a Foxglove something.
Yeah.
Oh, hey, it's gonna. Oh, it thinks the wall is a cone again. Crap. Oh well.
So.
Yeah, one thing I another thing that I had to deal with is, let's stop sharing, is the ROS Navigator. Oh, didn't I stop it? Yeah. The ROS Navigator had a strange thing going on. It was when I was switching between the Navigator, and I waited till the Navigator says I'm finished, and then I started issuing commands from myself to steer the robot. I was getting extra commands coming from somewhere. It's like for about 2 seconds. And so it was like chattering around because there's two different navigators were trying to navigate. And I couldn't find any way to really cut off the navigator. So I did something crude. I said, okay, when I'm switching between the navigator and my navigation, I wait 2 seconds for those commands to stop. And then I continue. Then I go on, and they're not fighting that way. So that was really weird because I thought when the navigator says I'm done, it was done, but it was still spewing out commands for 2 seconds and winding down. It hadn't quite wound down its operations. I'm still, I hate to say in shock, but I'm still bewildered. It's like, why is it doing that? So I didn't really notice that problem when I was doing a similar thing on my Robo Columbus code. So don't know. No, that's my show and tell. And
maybe they can. I'm sure they can stitch it back together again once they put it onto YouTube.
It'll be a movie break.
I'm confused because I guess I didn't read it.
Yes, read the fine print before pushing buttons.
Press this to end call for everybody. Press this one to end the call. Not.
Yeah, I think we need to reconsider Mike's privileges there.
Okay, so turn it back
companies
on.
are good at putting the buttons in places you don't want them to be. I've noticed that, yeah, they're inclined.
Yeah, because you can see here
for his robot operators.
Oh yeah,
too.
that red.
There's just a red
button.
button to end the call, and when I press that red button, it ended it for everybody.
Oh, so you couldn't hang up.
You were the host, though, right?
So,
Maybe don't be a host on a cell phone.
Well,
is there a way we can not do that?
I don't.
I mean, I can remove your cell phone from the call. Would that work?
yeah,
So you don't have leave call when you do that?
Yeah.
Oh, well, I hover over it says leave call, but it doesn't say end the thing.
But you're on
Yeah.
a computer,
Yeah.
right?
Yeah,
Yeah.
I'm on a computer though, but
Yeah.
I hover
on the
over
computer,
the thing that says leave call.
yeah. If I click leave call on the computer, it'll ask me, do you want to end it for everybody or just yourself? But when I press it on the phone, it just hung up on everybody.
So now we know that the phone operating system is not as good as we need to talk to Google Meetup. I wonder how many other people have problems with that.
Android, Windows, limitation
Yeah.
there. Doesn't always work okay on both,
That's true. It could be Android versus whatever difference.
So the question is, where were we? I know, Mike, you're still talking about ROS 2 and the issue. You're having an issue with ROS 2 Navigator or something, switching back and forth, getting multiple commands.
Yeah, when the navigator was getting close to the cone, and it says, okay, I'm close to the cone, so this distance away from the cone that you told me to go, and I'm finished navigating. Well, for some reason, it would still spit out navigation commands, like the command velocity commands, for 2 more seconds as it was winding it down. And when I was trying to navigate it myself using the LiDAR and stuff, it was getting navigation velocity commands from 2 different sources, and it was just acting really weird. So my solution was wait 2 seconds.
Yes.
I couldn't figure out how to tell when it's really finished. I might look at it some more.
Are you allowing multiple sources to drive command vel directly?
Well, that's natural. Like your joystick can control it, and the navigator can do it, and you can send command vel messages with your own navigation type software using like your time of flight sensors and stuff.
Yeah, the minute you get into that, you want to start putting an arbitrator in the loop, right? So you can post like joystick to command vel joy, and then like other things like your navigation stack to command vel nav, but only one of them should actually, your lowest level control should actually send command vel to the motors. And then you can use that as your arbitrator to decide which one to allow, so you don't have them stomping on each other.
Yeah. But I figured once the navigator said your task is finished, it was finished.
Such trust.
But it still spits stuff out for 2 seconds or so. That was like a day's worth of scratching my head.
Very cool. All right.
I'm done.
I say welcome back to the everyone that dropped. Mike accidentally found the hang up button on his cell phone, so yeah. So this is part 2. So maybe Paul can splice us together when he creates a YouTube video. We'll see. All right, Doug, you're up after Mike. I'll find that mute button. It's there somewhere.
Still can't hear you.
Okay. So since Doug is not responding to his mic.
No, he's trying. Oh, there we go.
Yeah, I'm just trying to get this other thing going. Entire screen. Okay. Let's try this. All right. Okay, do we see anything? Yeah, okay.
Yep.
Yes.
What is this saying here? Representing
real-time serial capture.
Your entire screen, or okay, I don't know.
Yeah, we see the whole desktop.
Okay,
is that you on the rock?
Yeah, that's me.
Oh, nice.
Yeah, that's McCaffrey's knob in just north of Damascus. Roanoke in Virginia. Let's see. So what I want to do, if I can find it. Yeah, here it is. All right. First thing I'm going to do is talk about my RTK setup.
Oh, cool.
Okay. If I can get it going here. Okay. Put it over here. Take this over there. I'll make it big. Okay. All right. So I'm just showing you what I'm doing here. Okay. So this is the mobile unit. It's just sitting on my desk. All right. And then if I look at, so this, if you just to show you where it is,
Yeah, get in the picture.
It's in a room. Oh. It's gonna force me to change every one of these things. Okay, so it's in a room. So my robot's in a
Not
house.
a lot of windows there.
Yeah, it's in a house. Okay, and my base unit. And why I was doing this was to say, well, this is probably worse than anything that I'm going to be doing out at. So my base unit is underneath my patio cover, just sitting there, chunking away.
On purpose? Yeah. You're trying to get worst case scenario?
It kind of, and I was able to achieve, what they call RTK fixed with this. But, so being new to RTK, I wanted to try some things out. And the thing that I learned that I didn't know was the base unit I'm not tying it to a specific known location. Okay. So it has to figure out its location every time it's turned on. But when it does that, it doesn't actually get the exact same location. It's within probably a yard, but when you set it up and turn it on, each time you turn it on, it goes through capturing data until it gets a good RTK fix, and then it says, okay, and I don't know if it does it through averaging. I don't know if it does the first point. I'm trying to find that out from the vendor, but it's going to find
called survey in mode, and you need to let it run for a really long time. It is right. Sort of averaging.
Well, that's
you can do a trick if you can also get it from like RTK to go, right? When you're first setting it up, you can get an actual RTK fix in almost no time, and then use that as your reference.
Yeah.
So you just need to hook it up to the internet one time, and then you'll get a nice, good solution. But if you're using survey in mode, I don't know for your particular manufacturer, but that's typically what it's called, and that can take hours to resolve, although, within the first 10 minutes, you're starting to get pretty close.
Yeah,
but you're right, it will be a relative fix that you're going to get off of it until it's really, really zoned in.
And then I started to think about this. Do you all recall at the last Robo Columbus, Paul was using RTK, and he used the RTK values that we gave him as the coordinates, and they weren't quite right. He got very close, but they weren't quite right. And then he retook his coordinates and then got it on. So I can't remember if he was using his own RTK antenna. Does anybody recall? Or was he hooked up to Steve's?
I wasn't there, so.
I thought he was carrying around a tripod with him.
Okay, so he was probably setting up his own base station.
Yeah.
And so he probably ran into this issue. Okay? Otherwise, he was hoping for it to touch the cone solely by using RTK. And once he went around and got his own cone coordinates, he was able to do that. But I suspect what happened was, his antenna or his base station did just exactly what Kareem said, which is close. Probably puts you within a yard. You know what I mean? But I haven't let it run. This is being run by this battery pack. Can you guys see my cursor?
Mm-hmm.
Yeah.
Okay, there's a battery pack here. That battery pack, I know it will last at least 12 hours because I had it running 12 hours. And I just ran it, I just turned it on, and I've now got a fixed, an RTK fixed solution. And when I plotted, X number of points, like something like 1,000 or so points,
the devil himself just joined. You can ask him.
Yeah, it just said, "Boop," it's there. You know what I mean? No variation. It's just there.
But Doug, can you tell it where it is if you know where it is?
Oh well, I did. Okay, so I took I didn't get a picture of that, but we can probably look at that. Give me a second here. Okay. What am I trying to do? Okay, this one. Let me. Okay, so what I'm going to do here is I'm opening up a tab, and I'm going to Maps. All right. Right. And then I'm going to go over here and pull up this current location. Okay, now this 5 means that it's actually in float. Okay, right now it happens to be in float. I did see it in fixed earlier. So if I put this coordinate, where is it? I guess it's here. 32.995830 space minus 96.674804. Should be able to just go there.
We're not seeing your Google Maps.
Okay, yeah, I'll bring it over in a minute. All right. So this one is actually a little off.
Yep.
It should be, when I was doing this earlier, it should be where my cursor was. This is an outbuilding, this little thing. It just thinks of it as part of the house, but what happened to it? I don't know what happened. But it should be right here. So it was off a little bit. You saw where it was, right?
Yep.
Yeah, pull it back. Yeah, there. Yeah.
So I wonder if it's just the pin. Yeah, it's the pin. Huh.
Well, like I said, I did this yesterday. How this is demo mode stuff. Yesterday it was right on. It was right over here. So the question was whether it was on one end of the desk or the other end of the desk, So actually I'm pretty pleased with this. And what I'm thinking, this is a nice solution, okay? But you might want to be able to, like Kareem said, get RTK and have that set up. But how you could do that, I'm like Kareem. I bought a couple of, what's this modules built based on, Kareem? What is the name of it? Do you know?
Quacktail?
Huh?
I think it's Quacktail.
Quacktail?
Quacktail.
Octal, okay. Well, I bought an Octal module, base station module. So I could actually set that up and put it on 4G and on a Raspberry Pi and put that here. This is so easy to use, though. You literally just plug a battery in the base station and it's chunking away. And on the other guy, it's just your robot. You just power it up anywhere between 5 and 10. So if you're using 2S batteries, which I'm not, but if you were, you could just power it off the battery. I'll have to use a regulator. So, well, actually, I'll probably plug it into a USB port on the Raspberry Pi and let the Raspberry Pi power it.
It'll work great until somebody accidentally steps onto your transmitter.
Oh, well,
bumps over your tripod.
Depended on the robot. So, the second thing. So I just wanted to give people an update, and So there's a few little gotchas that I'm still trying to work my way through. For example, I want to build a nice little tray right here on this part of the tripod, so I can just put this over here. You know what I mean? But as opposed to duct taping it to it. But you know, duct tape works too. We'll see how it ends up in the end. But this, like I say, it's surprisingly easy to use. They have example programs. They have everything, a good library. Everything seems to work. So that was the thing I wanted to bring there. So now, let me see if I can. Maybe
that's pretty nice that you can get a signal inside. I very rarely do, and I have a lot more window in where I normally test.
Well, I haven't done it. Okay, so here's, when my robot's running in the yard, here's my test course. I put the robot facing that way, okay? Mm-hmm. So, and that happens to be facing south. And I put the cone over here where you can't see it behind this gas grill. So the robot, when you turn it on to tell it to go to the location and find the cone, usually does a pattern where it comes around here and does a turn, and as it faces the cone here, it sees the cone and then drives to the cone. So that's going to be my test pattern. And then when it does that, then I'll try to put a cone over here in this area and have it drive from that cone back. But that's probably a couple of weeks off because I'm going to be out of town for a bit. So the next question, one of the things I wanted to show you was I'm updating my robot, and I was telling you I was trying to get some wheels on it.
Quickly, Paul, the question to you earlier was, were you using a base station at the last RoboColumbus, or RTK2Go or something like that? Can't hear you.
You're muted, Paul.
Unmute.
Sorry, thanks. RTK2Go based on Steve's base station. So Steve has a base station at his house, and he's publishing onto RTK2Go, and then I was pulling in the RTK2Go data using a cell phone. So yeah, I wasn't using a base station. Other than
that goes one theory away. Mm-hmm. I was wondering, why did you have to you went out and measured all of the cone positions. Why did you do that?
Because the coordinates that the script accepted were relative to some local origin, just to make it easy to deal with, easting and northing relative to a local origin that was in the driveway of the neighbor across the street's place. So I set up the rover in the driveway or next to the driveway of the neighbor across the street, so that all points that the robot would want to go to were north and east of the origin. And then I went around to all the cones, and they all had positive numbers for north and east. It was just a convenience thing.
Gotcha. Okay. Yeah.
That's a lot of trouble to go through to not have to deal with a minus sign.
Minus sign, yeah.
Yeah. Well, let's see here. Then I guess the other question I had was going to show. So anyway, I was working on that robot, getting the wheels exchanged, and I just printed at the start of this meeting the last pieces that I need. And this is what it looks like right now. I've got one more side to finish. It's going to come over here, guys. I know it's slow. So, come on. So, halfway done. You can see I've got the tensioner in there now. And I actually got probably 10 minutes of assembly on the other side to get it together. So, literally, that's how close I got to having it ready for today, but not quite there. Anyway.
Is there a suspension? Is there a suspension there?
No suspension, just tires.
Squishy tires.
Squishy tires, yeah. But this is got a spring in it. Okay, so if the tension on the belt suddenly changes, it will adjust within a certain range on that. Okay.
Oh, is that a single belt driving 2 tires?
Yes. Yeah. I know it's not the most robust drive system, but I kind of got into that at the beginning of the year, and I'm taking me. Yeah, it works. You know, it drives around. I haven't tried it with the new tires, but the setup should be actually better than the old setup, so I'm hoping that it'll do fine.
Do you have a beefy deep tooth belt on there, or? It's
the wider or the most common Amazon belt that you can get.
Oh.
You know, if I were doing this again, I would either go with a chain drive or I would go with parts from what's the name of that? Rev. I'd probably go
build a, yeah.
Yeah, or go build a, go get one of the ones that are a little more robust. But I am where I am, So
that's good.
So hopefully,
yeah. I have this question. I know on the smartphone setup that I have, in survey in mode, they suggested I think it was like 300 seconds, which is 5 minutes, and I want to say it was either a meter or 2 meters, and if it reached both of those, it would basically go into like RTK base mode. And but if it's something is that can only locate itself within even say a meter, how is it predicting 2 centimeters accuracy on the rover?
So this is the whole problem with repeatability and the definition of accuracy. If when they talk about those 2 centimeters from a particular base station, once everything's calibrated, you should be able to reproducibly get to within 2 centimeters of a previous location relative to that base station. If your base station is wrong, if your survey mode has it like offset like a half a meter or something like that, then all of your stuff is going to be half a meter away from. Let's assume that Google Earth is the king and actually has good super accurate GPS tying to like a particular rock that's been surveyed or something like that, then yeah, your results may be different, but they should be consistent across your run as long as your base station is working.
Yeah, and the thing that it seems to me, just from the limited little running that I've been doing, that what it really does, is if any of you've taken even a GNSS and set it up and watched it, it'll have a very tight Gaussian distribution, except for when it's running off into the woods. And that's what you want to stop. This doesn't seem to run off into the woods.
Yeah, it should not drift as long as your base station signal is solid.
Yeah.
But it may not. It may be relatively accurate versus absolutely accurate.
Yeah.
And ultimately, everything is relative because, continents drift too.
That's true. That point's not fixed on the Earth.
Yeah.
Tectonic plates,
Exactly.
Yeah. According to
Australia,
the AI guy,
up towards the continent.
The continent moves 8 centimeters a year. Just so you know. That's
Is it that much? Wow. It's quite a bit.
Yeah, but Australia, I think, is moving inches a year.
Yeah.
Hey, I'd be happy with that much accuracy on my rover.
Yeah. Like I say, what I found in my practice runs last year, because I didn't get actually to run, was that what you would find is that when you were far away from the cone, being off a little bit is not a big deal. It's when you get closer to the cone when you're being off is a bigger deal. And so like when you're starting off, you can start off pretty loosey-goosey. So anyway, I don't know. I'm just playing with it. We'll see how it goes. But for $169 or whatever it was, I thought it's not a bad solution. I mean, I think just a normal M9 without RTK is probably $60. I don't know though. I went to look for a battery for a car, and the cheapest battery I could find was $250, and I was going like, holy macaroni! I remember when we used to buy batteries for $100. But anyway, those days are gone. So anyway.
Not unless you get your batteries at Walmart. So you might still be able to get one for under 100. So the value line.
Yeah. That's the one where
only good for a year,
they
though.
take 2 D cells together or something like that, huh? Yeah. Yeah. Anyway, so that's what I had to show. I just wanted to show some progress on the robot and some further thoughts on the RTK purchase I made. So yeah, that's it for me.
Yeah, I'd be kind of curious how, if there's going to be any interference, or is LoRa going to cover the distance that you want? Because if you kind of set it in the center of the 3 points, roughly, it may be probably less than 100 yards, you think?
Right now, that's the thing. Right now, they're pretty close. They're probably 100 yards from the base station to the thing. But, I put a lot of interference in between it. And the real intent would be to put it out in the open. Mm-hmm. Now, and if this, I'll be quite honest, I'm thinking about this, and I'm thinking that since I have that other module, because I've been pursuing this for a year and a half. And so I have the other module available, which would easily allow you to do you could use a phone module. But now here's another thing. It turns out that you can pop the bottom off this box. I haven't done it, but who knows what's in there? It might be an easy way to just hook up a 4G card. We'll see.
I think you could, Doug, because I spent some time last meeting studying the schematics of the sender of the base station and the rover board, and both of them have a 4-pin connector that clearly goes off to a Bluetooth module that comes out on the other antenna port. And they don't show the Bluetooth module in those schematics that we looked at last meeting, but clearly there's no Bluetooth on those schematics, so that's where they have to have the LoRa I'm sorry, I said Bluetooth, but I meant LoRa. They have to have the LoRa module plugging in on that 4-pin connector.
Mm-hmm.
So you could substitute it with any other kind of bidirectional wireless transport.
Yeah, that's what I suspect that's true, Paul. And like I say, just to keep this guy stock and not mess with him, I probably grab that other module and screw with it. It should, if it's the same chip, it should work.
Mm.
Yeah.
That's a SIM 780 module, and I got an actual SIM from T-Mobile, and it worked pretty good. That's the 4G LTE antenna. That's the GPS antenna, because you can't buy a module now without a GPS antenna or GPS in it. So, and I just ran it off a single cell lithium-ion battery, and had a lithium-ion battery charger.
Yeah.
So, and that
what does that service cost
What's
you?
going in and out of it, Ray?
Just serial TX and RX.
Yeah. And does it have some protocol for like how you get to the internet from it?
Yeah, I think it was just came with the or somebody had done it for the Sim 7000 series, and that's a 780. And it was pretty straightforward to communicate with it. I was actually had that hooked up to my security system, but got a router now, and I don't have to mess with it. So I was sending like short little text messages to 2 cell phones. So to indicate, the status of the alarm, like if a door was opened, I'd just say, service porch door open, or, Pam overhead garage door open, or something. Just little short text messages.
What was the monthly service charge?
Depended on the rate, but if you did under, I think, 300 kbytes, it was, I don't know, like $6 or $7. And that there were 2 protocols you could send. I think one was, I can't remember now. It's been too long. Category something. I have to look it up. There were 2 protocols that you could get, and it's for basically sending low bandwidth telemetry data from some remote site that still has cell phone access.
Yeah,
basically. So I'll have to look up what it is. There were two different protocols, different limits on the amount of data. One was much faster than the other. As far as how much data you could send in a given time period. So, and they both had maximums for like the month interval. But yeah, like I said, I don't remember what it was, but I can look it up.
Yeah, I had an alarm that I put a cell phone on or a module, and I had a service for $10 a month. You could do 100 messages, and so basically a couple of days is $10. Yeah.
Yeah.
So it's something similar. Yeah.
Yeah. So yeah, they're fairly reasonable, and the fact that they'll, you pretty much hook up the battery directly to the part, so you don't even have to have a regulator between them.
Yeah.
So that's
my barn was in Oklahoma, so.
Those sound a bit too restricted for RTK to go.
Yeah.
Yeah. They did have different plans and stuff, but basically I just wanted to, send text messages that were fairly short, a few words, and hopefully not that often, because that would say that somebody broke into my house, so you don't want those messages coming across too often. So, but anyway, yeah, I'll have to look up what those were. There were 2 protocols that were supported for that kind of stuff, but yeah. Anyway, so you could do it. God, it seems like there should be an app for that. You just couldn't hook up you know, a USB, port to the phone on something, and use your phone as, set up with RTK to go, and there's not an app that'll.
Yeah, there is.
RTK to go.
There are a couple of them. Yeah.
Yeah. Yeah, I would think there should be.
I wrote one for Android, but there's a better known one that's been around for a while. But yeah, it just basically you use your phone's data plan to get the RTK to go signal, and you typically connect to your GPS unit over Bluetooth, or your robot over Bluetooth.
Oh, okay. Oh, all right. Yeah.
And just acts as a relay.
Yeah.
So, do we have a queue going?
You're next.
Do we have John yet? John was going to go as well.
I'm sorry. No, then John is next.
So are we ready? In that case, I'll click. Okay. This is what, hopefully, there it is. So this is, let me click more. So this is what I was talking about. So let me see if this actually will play. Because, uh-oh, what did it just do? So hopefully you're all seeing this.
We're seeing the webpage.
Okay, because my screen just went blank. But anyway, basically there was this article. It shows this robot doing a couple of things. So I may, have to reboot. So when it's finished, tell me.
You can get one. Try it out.
Well, that's that robot that I said was. If you run that, discover that it says basically there's that $6,000 robot right now that they have in that image there, and seemingly they're looking to upgrade the software for it. So right now they're showing, basically it does three things, as far as I could tell: wash windows, vacuum, and take out the trash. I think was the other thing. So.
God, washing windows, that sounds a little risky.
Well, yes, could push a little 2R on it would be.
That's right. Ooh, there's a spot on here. I can't seem to get it off.
Well,
I wonder how good it is at falling over.
What's that?
I wonder how good it is at falling over.
Oh, yeah.
They never seem to show you that.
Does it just face plant, or does it have some fall protection? Sticks its arms out or something.
So anyway, once I get the window back, I'll log in because it looks like I need to do a little more to get my window under control. Back here. So anyway, I'm going to log off for a little bit because I can't turn it off any other way. So I'll let the next person speak. So bye for now.
Thanks, John. Well, yeah, John was the end of the list. So if any of the newcomers have something to present, feel free.
Yeah. So I got something to share. It's exciting news. A new robot. So let's see if I can pin myself. So if someone pins me, I guess I can pin myself. So this is a Maker's Pet robot, and it's a ROS 2 compatible robot. It actually has the same architecture as the Lino robot software stack that I've been working on. There's an ESP32 board here. mounted on a carrier board that has a couple of motor drivers and an encoder sensor on it. And then there's two N20 motors tucked under those white housings in there. And I just got it on Saturday. It took about a couple of hours. I spent a couple of hours assembling it. Haven't screwed the LiDAR on, but the LiDAR goes on here, and like so. And then the couple of 18650 batteries in there, and so I've gotten as far as loading the firmware on it, and so Maker's Pet is kind of interesting. Here's a little video of the thing running. Let me see if I can just get this to a more reasonable format. There we go. So there you see RViz on the right, and
you're not sharing anything.
Oh, sure.
Sorry. Share. Okay, now are you seeing the little robot on the left and RViz on the right?
Yep.
Mm-hmm.
So the robot runs across, and you can see on RViz it's navigating across the open space, and you'll see the arrow pop up as he clicks navigation points here and there when it arrives at a destination. So here it is navigating around some chair legs, and there you see the arrow the green arrow where he set a new goal for the thing. And again. So anyway, this is what the thing is supposed to do. The video series for assembling it is excellent, and it's real simple to assemble. So they have a series of YouTube videos. The assembly video, which is what I've done so far, the software and firmware setup video. I'm working my way through the later parts of that, and then the robot bring up video, and then creating a map, self-driving the robot, and they support. And the nice thing about it is most of it is written for and videoed for use with Windows. And actually, what it really does is it runs ROS 2 on Ubuntu in a Docker container on WSL2. So it really is running on a Windows PC inside of WSL2, but the Docker container with an Ubuntu image in it gives you the whole ROS environment. This is are you seeing the price list here?
Yep.
Okay, so you can kind of see the Motor 1, Motor 2 terminals, enable. Anyway, so what's interesting is $150, pretty reasonably priced. I think Minibot ended up costing me about that. But you can subtract items from the 150 depending on what you don't want, what you want to provide yourself. But so you can subtract out the ESP32 or the motor driver board, the motors. If you want to build your own chassis, the LiDAR sensor subtracts 55. So you could get a LiDAR-less, so a sort of like a basic run four square or tabletop kind of robot for $95. Or you can print it yourself. The files and design files are all online. So let's see, they're all online in the repo.
Looks like it has a Nito style LiDAR in it.
Yes.
Yeah.
It will work with. It can be configured to work with a variety of LiDARs, like a Lino robot can. Firmware. Here's a platform firmware, and I believe this has the mechanical models. No, I guess not. I don't remember where the mechanical models are. I found it, but I can't lay my hands on it at the moment.
What advantages does this have over the one that you were working with before?
Well, the advantage for newcomers to robotics is it's off the shelf. You can order it. It doesn't require you to design anything to know enough to select appropriate parts and design a 3D printed thing and a circuit board and solder it all together. It's really pretty much screw in some screws and plug in some wires. And it's cool. So I think for beginners, this is a real easy start to both non-ROS and ROS-based robotics. Easy and inexpensive. And so let's see, what else do I want to say about this? I've got it. I've got the firmware loaded, so it uses the Arduino 1.8 to run the firmware on the ESP32, and it is dependent on 1.8. You can't use the 2.0 version because it uploads a SPI file system to the Arduino that then presents a web page, and so the ESP32 firmware opens up, starts a web server based on the file, based on an HTML file in the file system that you upload to it, and then you can use that to tell it that's how you configure your home SSID and password, so you can get it on the home network. So then you get it on the home network, and you tell it what the IP of your laptop is, or PC is, and then you fire up Docker running their ROS code, and so it's running micro-ROS on the ESP32, and that connects to ROS, the ROS2 agent, to the micro-ROS agent in ROS in the Docker container. And after that, it's all just ROS stuff, and you got RViz and all the topics and all the ROS goodness that you would expect. So it really is a very comparable product to Lino Robot in terms of functionality, but the big difference in my mind is you can buy the hardware and it comes with good
that's a big advantage.
And ROS goodness, an oxymoron for me.
I was going to say something like that too. ROS goodness?
So anyway, I just wanted to share that with you guys. It's of interest to me because I'm now a maintainer on the Lino robot stack, and I think it should be able to run Lino robot just pretty much out of the box with some appropriate changes in config files to make it work for Lino robot. And I think it's an interesting product for getting started with a low barrier to entry, both cost-wise and hardware skill-wise, to be able to run either ROS or non-ROS robots. So anyway, that's what I think. I think it's the coolest thing. And
does it have a gazebo model?
I have found a gazebo repo, and it has instructions for how to start gazebo. I haven't tried it.
That's even the easier way to start.
Yeah, even easier, right. There is one thing. Let's see, am I still sharing my window?
Yes.
There's one thing that I did want to, one other thing I wanted to share about, and let me just find out where it is, because so MakersBot and KAIA are run by the same guy out in Los Angeles, and I actually exchanged email with him the other day, and his name's Ilya. He's I guess maybe Eastern European guy, I don't know, but the voiceover is all like AI generated American accent on the build instructions. But they've got a range of robots that they're working on. Here we go. They aren't on the store at this time, but they appear to have developed this loci robot, which looks like sort of a mini trash can with a phone in it that can give it a face, apparently. And the Fido robot. So like I say, these aren't on the Maker's Pet store, but they're in the Maker's Pet repo. This looks like, I don't know what Fido is meant to look like when it gets built, but you maybe get some sense of it from this. So all kind of variations of a differential drive robot, and there are config packages that are aimed at those different robots. Snoopy, another variation of the round dome with a phone in it. The one I've got is the Mini, and that's the one that you can order off the website. And so I ordered it on Tuesday. It arrived on Saturday, and took all of a couple of hours to do most of the assembly. And they don't have you screw the LiDAR on until you've got everything programmed, because you need this USB cable sticking out the back. So anyway, that's what I got.
I was going to say his last name wasn't Kiryakin, was it?
I'm sorry, I don't know the reference.
Oh,
Man from Uncle.
Man from Uncle. Yeah.
Oh.
Yeah.
So anyway, that's what I had. Hopefully by next meeting I should have the thing navigating around my office. So, we'll see. But that's a pretty low lift to get a LiDAR navigating map-based robot.
Very cool. Did anybody else have anything?
Well, I was examining my foxglove plots, and remember when it went through the hallway and then it sort of decided the wall was a cone? So I could show you the plot that I saw. So let me share that. See, there it is. Yeah, so I blow it up, and this is where it went to using the my own navigator, and so it looks like it was getting close to the cone. The orange line is the angle, so it was driving, and then when it got to the angle here, it sort of overshot a little bit, and it was trying to pull in to point directly at the cone, and then something happened. So tomorrow maybe I can reproduce it and figure out what happened. But you can see here it should have just settled down and then touched the cone eventually. Yeah. So that's an interesting way to use the foxglove to plot out your command veil commands and see what's going on. Because this is just you can see there's the command veil linear X and the command veil angular X. So I use this for debugging. I sort of look at it and say, oh, what's going on there? and helps me debug it a bit. It's a lot easier than seeing text on the screen. So that's that's what I had as a little update.
One of those points are free will, decide, okay, I don't want to do that anymore. I'm just going to, jerk back and forth here, try to get out of this algorithm or something.
Oh yeah, it was doing that back here. Yeah. So this is while I was in the Navigator. It was jerky around. I don't know why the Navigator does this so jerkily, but that might be because my cone, my AI doesn't have a really steady cone detection. It sort of moves the cone around a little bit. So maybe that's one reason. But it was homing in on it. Said, okay, that's as far as I'm going to get. So then it passed it off to the other cone detector, and it pulled it in, and it was almost pulled in, then it got confused. So, but this cone detector software here is only a couple hours old, so this is basically the first time I've stressed it.
It looks
I'm going to stop sharing.
Looks like your velocity went to 0 for a while.
Well, yeah, I thought the Navigator gave up, but it was still doing something. I noticed that
okay.
even though it's a wheeled robot, a non-holomic, it executes a spin command.
Right.
You can't spin that kind of robot, and so when it's doing a spin command, it sort of doesn't do anything. It says, "Oh, nothing's happening," and then it goes to something else. So I'm not sure why the Navigator, when it's using a Ackermann model, decides to try to spin. It's the craziest thing. I need to go figure out how to fix that in the behavioral tree. I tried to comment out the spin, and it says, "Oh, I need to spin. Where's my spin module?" It's not that cool. So I was amazed. Like, I'm going to spin my car. You can't do that.
That's interesting.
Yeah.
Well, maybe spin is interpreted as, jerk the wheel hard left and, go forward or backwards, that wheel.
But you saw that plot there was just doing nothing. It's like, I'm spinning.
It does nothing.
Eventually it figures out nothing's happening.
Yeah, that is weird.
Maybe they had it coded up for something like the Rivian, where it can do the tank turn.
Maybe.
Got four independent motors.
Oh, it does. Wow.
Well, some of them did at least. Not very good for the tires or the road, but
yeah.
or probably the whole drivetrain, right?
If I could steer the front and the back wheels, it could actually spin. But So Paul, you're going to have a show and tell in a couple of weeks.
So I'm hoping. I hadn't really thought about that because I think by the time Kareem shows like the combined behavior of his robot, both understanding a scene and responding to commands, and then I give a talk about why hobbyists what value hobbyists can get out of Git and how to do that. I don't see that we'll have time.
It'd be beneficial.
Yeah.
You know?
Yeah. Yeah. And I was thinking if we're doing that GitHub, I exclusively use GitHub using VS Code, except sometimes you have to go to the command line just to get it to do something. But so I was thinking, and then if you have VS Code, here's how you access GitHub.
Guys, I need, Paul and Kareem, I need you guys to send me a couple of sentences so I can put out a post. Because, I hear you, but I don't know exactly what to post. I could say Paul's going to talk about Git and
Kareem's going to blather for a while.
And Kareem has got some got. I don't know what that is.
He's going to wave his arms and
So if you send me just a couple of sentences, they don't have to be super detailed.
Will do.
Will do.
Don't tell me, just send it to me, because my brain doesn't have the retention it used to have.
It may not be anything like what you originally thought, too.
That's right.
Yeah, because when I use Git, I don't, since I just am a single person working on the project, I don't make branches. So it's like going, what's the advantage of a branch? I can understand branches for a team working on the same project, but I'm not sure what branches would do for me as an individual.
I think if you're adding new features, Mike, it can bring something to the
potentially rollback or switch to another branch depending upon what features you want.
Especially if it's the more reaching the more bright area that you have in your upgrade, probably the better the branch. I guess you just have to say, I don't want to do any of that shit. And
let's say you have a presentation coming up and you have this really complex thing. And then that, well, it's working right now. I shouldn't touch it, but I want to go do this other part to it. So at that point, it would be a really good idea to make a branch. And then when you go along, and then it suddenly fails, you can say, well, screw it. I can go back to the one that just works. So you just say, go back to the old branch. And
or you can have another branch that can go off in the middle somewhere and go into another branch or combine the two branches together eventually. So there are benefits.
Sounds like we're afraid of living on the edge.
You mean Kareem living in permanent demo world?
Well, I mean, you could do it the other way too, right? Because as long as you have relatively free, as long as you commit something once it's working, you can always go back to some middle of the main branch commit if you can find it. But
yeah,
it's just easier to work with branches. I think.
Because I had to go back one or two before, but yeah.
If you're going to be making some complex breaking changes, it's better to put it on a branch. So you never know if you need to go back and test your main line of code really quick. So yeah, even as a single developer, it's often a good thing to do.
I guess I need to.
Or you can live on the edge.
I guess I should start doing it.
You should. No, I think you should live on the edge of disaster.
Keep on the
Like
edge.
when I'm switching sensors, it's like, oh, let me try this other sensor.
Like when you merge, just always delete the branch because you'll never need to go back ever.
Yeah, don't do that. At least have one branch, one save, fall back.
Supporting multiple configurations is another scenario where you can have a branch that supports one configuration and a different branch that supports a different configuration. There could be two different robots, or there could be different sensors on the same robot being used in a different way. And then you can advance the main line forward with other fixes and changes, and then you rebase the sensor-specific variants on top of the new main line.
A lot of reasons. So there's your presentation, Paul. It's all outlined now.
Thanks, guys. Hey, I don't think I have to do anything.
Because branching is all there is to get.
Oh, no. There's a lot more.
So in the meantime, since I didn't show you the one other thing I was going to show you, I think I can now. So let me try to share a screen and type thing. I went on the wrong buttons. Where's my share? Share screen. Window. Okay. So we're done sharing screen. Okay. What are you doing to me? Boy, in Premiere, don't share your entire screen. Share a tab.
This is the walking concrete block, right?
Well, I almost got it right. Let's see. I want a window. I want this window. Share. Share my screen anyway. Well, I don't know. We'll see if it overly complains. That's fine. That's happy. I don't know why it was going to complain. It said multiple windows. But anyway, so here's one article, and it looks like that they have a place that's open source, as you can see, and says that this place, VITA, how do you pronounce that? That it keeps a number of parts down, makes advanced robot accessible to. So I might want to look into that. It's designed for easy build. So that, yeah, mostly 18 mil components.
Yeah, it didn't look like it had motors in the knees, so I guess it uses tendons, basically.
Well, there, it looks like there are more there and there, I would say. Yeah, and then there's a line like running from there to up to that more.
Can you hit and make it bigger?
I can try.
It has a plus on the arrow glass with the plus. So I'm just wondering if the picture gets.
That help?
No, I still can't see what it's got at its knees. I assume it's some sort of actuator, but I don't know.
Yeah, that's what it looks like to me. That right there at the knee joint. But supposedly, built with ideal of being
it's got bony knees.
18 parts, bony knees. So yes, it's open source.
Sheet metal welding.
We use sheet metal basically. So go.
Looks like a refrigerator on wheels. That'd be pretty cool. I mean, on legs.
Yeah. It has supposedly radar.
SpongeBob SquarePants, I think.
Yeah, kind of.
Yeah.
But the key is mostly, easy to build, small model components for it, and it's open source.
Do they have a picture of it walking anywhere?
No, I didn't see it offhand. It was just an article I saw, but imagine you're seeing what you see there, so I assume it can walk. So nowadays they've gotten these pretty good walking, especially with those two. So I'm thinking it should.
I posted the link.
Oh, you found it? Good. Oh, I mean, stop sharing, and then we can actually go to the real link and click more. Because as I said, there's a couple spots in there where, that talks about it. Oh, this will do it.
Plus, you can hone your auto body skills because you're going to have to do sheet metal welding.
Well, I don't think there's much sheet metal to it. I mean, it looks like just a basic block. There's a piece of metal here that's been cut,
Yeah.
Yeah, I mean, looks to me like, in fact, it looks like just sack up of a couple pieces of metal. You just cut here and there a little.
You should look at the link I just shared.
Yeah, it's got some video of it walking.
Let me let you all share that then. Okay, so click on whoever wants to share that link and run it.
Graham, are you going to share it?
Okay. Some good diagrams here.
Oh yeah, let's look at that.
As I say, it looked like they try to make it simple and easy to build. It looked like so.
These look awfully similar to the CAN bus motors I've got.
Mm-hmm.
I would say that's not trivial
What's
assembly.
That is not.
Anyone know what Mujo Co means?
No.
Let's ask Google.
There you go.
Yes, Google will know.
Multi-joint dynamics with contact.
Thank you. So it's a simulator.
Yes. General purpose physics engine.
I guess, would you say that's got dynamic stability or no? What's this? There's static stability and dynamic stability.
That looks dynamic, but it also looks pretty iffy.
Yeah. Yeah, because it doesn't balance on one foot for very long before it puts the next one down and gets into a statically stable state.
No, it doesn't look actually statically stable at any point. I think it's dynamic all the way through.
Really?
Especially with how narrow and small those feet are.
Mm-hmm. They are narrow, aren't they?
I think it's dependent on keeping the motion going in order to maintain its stability.
You can see it lean forward and backward a little bit.
Mm-hmm.
It looks kind of iffy compared to Boston Dynamics.
Yeah.
Yeah.
They're the best.
I suspect this is a lot cheaper build.
Yeah.
Open source.
It's a much leaner power budget, too, I'm sure.
I would factor that into the equation.
Looks like somebody with bad knees or a bad hip or something.
Feels like me. That's what I feel like.
You know?
Yeah.
He's using the handicap ramp.
Yeah.
Interesting.
Yeah.
Did they say how much it costs to build one?
Probably not.
All you need is a plasma torch and a MIG welder. You're all set.
Yeah.
You'd be amazed how many people have those two things nowadays.
So it's a 20-kilogram robot, so about 44
Over
pounds.
40 pounds. Yeah.
I thought that was interesting.
Yeah, that was.
Especially since, it was relatively low component parts and open source was some key things I saw from it. I was like,
Well, need to get it to find cones. Get it to find the cones and bring it to competition.
John, if you're talking, you're muted.
Looks like
Well, guys, might be that time. It's 9:15.
Time to
Adios,
bust a move. Bye.
Thank you.
Take care. Good night, Joe.
Bye.
Bye.
Can't stand by. Okay.